Kevin Layden, Board Director of Electrified Powertrain Engineering. And I want to welcome you to the FEL building, Ford Engineering Lab. And we're going to talk, as we mentioned, about electrified powertrain engineering. And this is really an appropriate place. We look what Henry started here, one of his early buildings, and that push for efficiency, democratization of technology, opening the world's roads to mankind, and really driving efficiency in both the vehicle and its use, as well as the vehicle delivery. We're building on that heritage, and it's an evolution. And if we look, our electrified heritage, it's not short-lived either. We're going back to 2004, when we started with the Escape, and up till 2015 now, where we've got fusion energy, C-Max energy, C-Max and fusion hybrids, the MKZ hybrid on the Lincoln side, as well as the Focus Electric. So if I look at, what does it take to make a good electrified vehicle, a good electrified powertrain, whether it be a BEV, a plug-in hybrid, or a hybrid vehicle? And you start looking at how many subsystems does electrification touch. It's really easy to count up a quick 20 that have either major modifications because of electrification, or actually completely unique because of electrification. And things like the engine being specific to the electrified powertrain is one, electric AC compressor is another, and then things like the regen brakes. All very important, all with true experts at Ford. But I'm going to touch on four specifics. I'm going to go through the e-machines, the power split transmission, and the high voltage battery, along with controls and calibration for the software. And then you're going to get a chance to talk with some of our experts here on a little deeper on that. But to start with, I'll tell you about the power split transmission. So Ford assembled a team of experts back to the 2004 program and selected the power flow that we were going to use. And they evaluated series hybrids, MHPs, as well as the power split transmission. And the experts really weighed in heavily, and Ford committed strongly that we were going to do a power split transmission. We said it fits the small SUVs, the small vehicles that we were going to go for, and it's unique. It's actually got some real good design cues that Ford has, or design features that allow it to be more efficient, where the power takeoff comes from the electric motor, how that's configured, and if you look, that is one of the keys in our delivering great fuel economy. So with the design, the manufacture, the development, and the software and the controls of this are in-house. So how's that working out for us? If we look at this, what we haven't done, what we haven't had to do from 2004 is move from one architecture to another. We haven't had to move to mild hybrids and experiment with those. We haven't had to look at a rear-wheel drive. Can we make that work? And what we've seen is the customers like the vehicle. We've got among the best quality of any of the Ford vehicles, and actually any of the vehicles in J.D. Power. We've got great TPWs. We've got great durability, great reliability on the products. In fact, I think we're going to take you through a little later how our products in the Gen 1 are over 250,000 miles in the taxi fleets in California, and still going strong. We've actually got one customer, who's actually a secondary customer. He runs a security firm, and what he does is he waits for the taxis to get to a point where they can't put any more miles on it. They've got to give up the vehicle, and then he buys them because he figures they're durable, safe, and solid, and continues them on past the 250,000 mile limit. So if you look at what's happened here from 2004, we see our sales continue to grow. We continue to have customer acceptance, and we haven't had to change that. It allows us to reuse that technology, reuse that investment without burdening the company with costs that the customer really doesn't want to pay. If we go into the e-machines and electric motors, it's hard to say that this isn't really one of the core technologies, right? This is a big deal. The electric machines, and we know that to lead, be a leader in electrification, you got to have this expertise. You got to have good power and torque. That's great. But if it's got bad NVH, if it makes noise that the customer's not happy with, that's not going to work either, right? You got to have good power and torque density. We got to make sure these are small enough that they fit. We can't compromise on the package mix for the customer. Cost is always king. Customers always need to have this affordable. And in fact, Ford, that's one of the things we want to make sure we can do. The common person can really have one of these. But we also want to be able to stretch it. We want to be able to have a great Lincoln product. We also need to know that those attributes, along with great component and material sourcing, needs to be there. So we at Ford know that we have to have the depth and the breadth in machine design, development, and controls to make sure we deliver that. So if we look at, well, how's that working for you? We start looking at our cost progression. Between each design that we go through, whether it's in the series effort or if it's a new program, we're seeing between 10 and 20% cost reductions each time. And then when things happen, as they do, things like rare earth metals spike, huge spike in 2012. Major cost hit to everyone using a permanent magnet motor with rare earth metals, and I think the cost more than tripled. Because of the expertise we had in components, design, the use of the magnets, we were able to do substitution and drive those costs down. And at the same time, as our designs progress, continuing to improve those attributes of max torque, max power, and power density. So it's having that expertise in-house. It's a common theme you're going to hear. Having the expertise in-house to really drive the efficiency, drive the cost, drive the attributes, making it great for the customer. Now, one thing that's come up a little bit is, how much of your software do you do in-house? There's been a lot of questions about, is Silicon Valley going to eat your lunch? How are you going to ever keep up with the people that actually know software? And I joined the company almost 30 years ago. God, I hate to say that. And when I joined the company, we were writing our own software. Engine controls were in their infancy, but we were controlling spark, fuel, air fuel control, catalyst, emissions after treatment, and we were doing a great job of it. That's still happening today. We write the code, we have controls engineers that come up with the strategy of how we're going to control things, and we do a great job of it. And if you start benchmarking our costs associated with things like after treatment, catalyst, and so forth, emissions control, they're fantastic. So when I moved into electrified powertrains, it was a pretty easy transition for me. It was an easy and comfortable place to be, because our engine controls for electrified powertrains, in-house. We write the software, we write the code. Our battery controls, transmission, inverters, motors, everything's in-house. We have complete control of it. And you think, well, why is that so important? Well, it really delivers the attributes. And it's important to have control of your attributes, the cost, the turnaround, absolutely. At the same time, I'll make a point that not just the product software is important, but actually the test software, the development software. So if we start looking at things like the Hill lab, Hill is hardware in the loop, which means we're going to actually test the hardware with software. We have a great group of experts that, because we have that controls, that calibration, and that strategy and software development for the vehicle, we're able to create models and test those models of whether it's the engine, the transmission, the e-motor, and the machines on the Hill bench. So what we can do is we can reduce the testing time, eliminate the need to build hardware, which is god-awfully expensive in the prototype phases, and then fully utilize Ford's engineering team. We've got a team in the UK for electrified powertrains. We've got a team in China for electrified powertrains, and then we've got our hub here in Dearborn. So we're able to use experts from around the globe, as well as around the clock, keeping these things going. So you might say, well, how's that work? Well, certainly, our quality is outstanding in our hybrids. One of the best customer satisfaction vehicles on the planet. We continue to get good feedback. The engaged driver that we have, the quality is great. It does speed our innovation. These are things that are difficult to quantify, but one thing I'll show you is that if we were to do a test manually, and I think Tom G's going to take you through this a little later, 1,200 hours, almost 30 weeks. If we automate that, run it through our simulation, it's done in 10 hours. That's freeing up engineers to do other things that really matter, things that can really add value to the customer and continue to take cost out, something we're really proud of. Battery expertise. This is a bit of a media darling. A lot of people are talking about batteries. There's actually conferences on batteries, how's the cost moving on batteries. And the question we continue to get is, who do you get your batteries from? Who's your battery experts? Well, I will say that the Ford Motor Company, this is one of our strategic advantages. We have battery experts inside Ford Motor Company, and we have them in this room. And the knowledge they have is at the, I'll call it the electron microscope level. They understand what makes the chemistry work. They understand what makes the battery durable, what gives it the right power characteristics. And they help us select which partners we're going to have in the supply industry, and then we work with those partners to make sure we get good batteries. So if you start looking at that really great achievement, what else can you do? And one thing I'll point to is, you see we've got partnership going with the University of Michigan. And I think it's a $7.5 million, Ted, correct me, battery lab, or excuse me, it's a actually small-scale production facility for lithium-ion batteries, for the mixers, the coaters, the splitters, and it can actually make small-scale automotive batteries so that we can get a good look at new chemistries, really understand them, and continue to push for the right technologies. And I think, well, that's an easy one. You set University of Michigan up, and we're going to benefit by it. And absolutely, I know we're going to benefit by it. I also know that our competition will benefit from it. This is going to be the University of Michigan, one of the premier institutions in the world. And we know others are going to do it, but it's the right thing to do. We're going to make the industry better. At the same time, we're also going to make our supply base better. We're going to make suppliers, we're allowing the suppliers access to equipment that they wouldn't have. We're great to have great suppliers. That's a great thing for us. And then the last thing I'd say about it is we're going to get better shots at great chemists, great scientists, great engineers who are familiar with the type of batteries that we need. And they're going to get into the supply base. We know they're going to get into our competition as well. But this is one of the things we think is really helping society, and we really want to push this. And I encourage you, if at some point you want to get out to the University of Michigan and have a look at this. It's a fabulous facility and truly world class. So what's that done for us? If we look through Gen 1, Gen 2, Gen 3, everybody wants to know about cost. Our costs are coming down, and I guarantee they're coming down faster than anyone's predicted. And I look at all the analysts and what they've chosen as their numbers and where they're coming, and that's fantastic. And that's what everybody focuses on. But you should also be focused on things like volume. How's your volume doing? And if you look at Gen 1 to Gen 2 to Gen 3, the total volume associated with that battery is gone down to, I think we're about 30% of what we were with the Gen 1. And that's a big deal because, again, it's compromise in the vehicle. How much space do we have? Will it fit in a Focus? Will it fit in an Escape? Will it fit in a Fusion? And how much do I have to give up? The less you give up, the better. Additionally, we know that lithium-ion was a big stretch. Right? Ford Motor Company was the first one in North America to go into lithium-ion production. And some of our key competitors are really just now switching to lithium-ion for some of their high-end or some of their specialty-type vehicles. We've got lithium-ion across the board. We've got true expertise with it. We've actually made more lithium-ion vehicles than anyone else on the planet. So we've got the expertise, and that's what it's helped us deliver. So that cost, that expertise with each one of these disciplines and the other 16 disciplines that were on the chart really help us continue to drive costs down. You're going to hear a little bit more about this, I think, later from Mark.